Welcome to the first assignment of this semester, and we're going to be starting out implementing a scanner. And a scanner and a parser are the first steps along the way of building our compiler, and they're also incredibly important to every other stage that comes next. A scanner's job is really the first line of, I guess you could say, offense of taking our horrible code that we write as humans and transforming it into code that the machine can understand, aka tokens. And we'll get into what those are and what that means in a little bit, but we have to understand why we're even going about doing that. And if you think back to all the programs you've written in Python or Java or C or whatever the language is, it doesn't really matter. I mean, off the top of my head, I can just from like the last week think back to ridiculous decisions I made where I like threw new lines in places that didn't make sense. My brackets are all over the place, where sometimes I put them on the function name, sometimes I put them down lower. But there are all these design decisions that we, the humans, are making that are really superfluous to the code, right? If the bracket's there, we know we're setting the scope. We're talking in Java or bracketed languages. If Python, if we're talking about that, we know the indent identifies the scope. So in both cases, the real important aspect is the scope, or the fact that the brackets are even there in the first place, not where or how many new lines there are in between them. And that's the scanner's job. It's to identify what's important or what's really just superfluous in the human code that we write. And you can kind of think of it like an experienced chef, where as they're looking at a recipe, they can kind of realize like, oh my God, this person's putting in 2 tubs of butter. They're gonna go into cardiac arrest by the time they're 33. Don't need that. You only need like 2 tablespoons and you're good to go. And that's exactly what a scanner is doing. It's looking at the human written program. It's deciding what is in the language that we want to keep, and then what is human generated that really doesn't matter. And it's also assessing correctness, right? Going back to our chef analogy, if you're putting like red pepper flakes in biscuits and gravy, you're probably out of your mind. The chef isn't going to do that. He's going to throw that out and tell you, you're wrong, get out of my kitchen. A scanner is the same thing, where if it detects an issue, it throws that out and says, hey, we have an error. We want to report that as an error, and we don't really want to accept this program because there's issues just on a syntactic level. So to build this scanner, we're going to be using something called a state table. A state table, you can kind of think of it like a 2D version of deterministic finite automata. Kind of like an Excel spreadsheet representation of the structured decisions and transitions you can make from state to state depending on what input you read and where you are. That's all it is. And I know that might sound a little bit intense, and when I did this the first time, really this was something I struggled on pretty hard. But you really just have to think of it like a video game. And let me explain that reference with this game that I've been loving called Helldivers. Helldivers is essentially a video game version of Starship Troopers, if you've ever played that. And you're basically fighting for democracy, doing missions. But there's this idea in the game called stratagems, which are essentially perks that you can call in at any point in the campaign or while you're gaming. And the way they implemented these stratagems is with QuickTime events. That is essentially a state table, and it's really interesting. So you can enter the state machine by pressing Control, and that really indicates that, hey, I'm ready to start going through the state table. And from there, you can select inputs, which are arrow keys, and each arrow key is a transition into a new state from the state you were previously in, right? If we're looking at the demo right now, you can see that I start in this neutral state, and by pressing right, I immediately go into this subcategory called, Eagle Airstrike, and we'll go over, that doesn't really matter, but we'll look at the 2 representations and we'll break it down from there. All right, so we're going to be drawing out the DFA for a subcategory of Eagle strafing runs. And we can see that when we press Control, we go into this S1 state, and if we press up, we can see that all 3 of our sub-Eagle strikes, this is valid, so we want to go into state 2. If we go down, let's just pretend this is a different subcategory, and we're going to say it's valid, but not something we want to focus on in this example. If we go right and left, we're going to transition into an error state, And we're double circling this to indicate that it's a final state, aka something we want to accept. So all Eagle attacks in this subcategory have a right as their second input for it to be valid. So if we go up and right, we're still correct and we're transitioning into state 4, but on any other input, we want to go to this error state, and then we have the user redo it. So if the user presses up and right twice, we're going to see that that's an Eagle strafing run, and it's a valid stratagem, so we should mark it as an accept state. But if we notice on the down key, if we're in state 4 and we transition on the down key, we're still in this intermediary where we can be in the Eagle airstrike or the napalm. So we have to indicate that by not a final state, yet another transition. And again, if they press an invalid, such as a left, we transition them into the error state and make them redo it. And that's true for S6 as well. If they press a right, we transition them into the Eagle airstrike, and that's an accept. And again, we're doing the same thing for if they press up, and that's going into the Eagle napalm. And again, that would be an accept state. Let's turn that DFA into a state table. And to do that, we're going to denote what state we're currently on, and then we're going to draw all the inputs as potential options for where we go from there. So again, we hit Control, we go into the S1 state, and from there, if we hit a left or right, we denote that we're going into our error state. If we go down, we go into S3. If we go up, we go into S2. And from S2, we can see that on pretty much every input, we go to error, except if we get a right, in which case we transition into this S4 state. Again, we didn't do anything with S3, so we're just going to send that to error in post. In S4, we have two options, right? We have the right arrow, which sends us into S5, or we have the down arrow, which sends us into a different state. On S5, we just go to this idea of accept, aka like a finished state, right? On S6, again, it's a transition where if we have a right, we go into S7. If we have an up, we're going into S8. And both of these are finished states, so I just send them to accept. Error, we restart and go back to S1. And for accept, we do the same thing. If you don't play any video games and you really didn't get that analogy at all, I apologize, but hopefully you can still kind of see the similarities and the state table as we were putting it into a DFA and then going into the eventual state table there. That's really the whole goal behind that. It's just a fun analogy to keep your attention. I mean, I don't want to do something like this where I have, this in the background to keep attention. Although it works for me on TikTok, I scroll through this crap all the time, but it really doesn't make any sense. So, we're going to wrap up and we're going to talk about the actual assignment, and I'm going to walk through some code to hopefully get you guys started and off to a great step on this assignment. So let's get into it. Looking at the top, we have a pushback reader import. I'm not really going to comment on that other than you might want to look at the man page and see how that may be helpful for this assignment. And then we have a state and character enums. And this is basically just defining a group of constants that are more flexible than your typical integer variables to represent states and character types. And we can map that to our current state or the inputs from the previous example, where the current states would be start, accept, etc. And the arrow keys would represent letter, digit, and punctuation. And then the actual 2D representation of our state table is in this edges 2D array, where we can take a look at start, where, if we take a look at that, it's being in our current state. When we are in our start state and we encounter a letter, we then transition into this ID state. And I'm going to leave you to kind of fill out all that information. And there should be more than just that. This is just an example here. And then we have our scanner and, of course, our main. And this is essentially just setting up all the things that will allow us, the user, to read in from a file, or, when you're starting out, maybe just command line. Actually, no, I think we'll provide some example test cases. So reading in from a file is probably your first step.